Hello everyone, I'm Tanya Gallagher, and this is part 3 of a 3-part series on QGIS. Today I'm going to talk to you about an introduction to cartography. Just an overview. In part 1, we discussed an introduction to GIS and explored the QGIS interface. In part 2, we discussed tools and applications in GIS and had 2 exercises, 1 working with attributes and 2 working with tools in QGIS. And in this part, we are going to discuss an introduction to cartography. For today, we will discuss an introduction to cartography with focus on the fundamentals of cartography, essential map elements, and examples of good and bad maps. In the following exercise, you will learn how to make a good map in QGIS and then make a map of your own of community forests in Liberia. Today's learning goals are to 1, gain an understanding of fundamental cartography concepts, 2, learn the essential elements for making a map, and 3, to gain understanding of how to produce a map using QGIS. So our big question today, what is cartography? Cartography is a convergence of artistic fields and traditional disciplines. So on one hand, we have this artistic design, and on the other hand, you have GIS skills. And then thirdly, you have this other part of cartography, which is storytelling. What do we want our map to tell people? So cartography is the art and science of making maps. And there are standard cartographic conventions for making scale maps. And these are the conventions that we're going to discuss today. So a map is a 2-dimensional representation of a 3-dimensional object. It's a generalized representation of the world. No map is ever completely accurate or complete. That's because we can only be a proxy for what's happening on the Earth. We're never going to be 100% accurate or 100% complete because things are constantly changing. However, with our maps, we can make the best representation of what's actually occurring on the Earth. There are many different types of maps and many different ways of representing data on a map. So the type of map that you use depends on several factors, which includes the data you have available and what it is that you want to emphasize with your map. So the following slides, these are examples of different ways to display data. So there are many different types of maps, as I mentioned. One is political maps. So political maps, such as the map in the top right, shows different countries in Europe. So we have Spain, France, and this is just a map of what's happening geopolitically, a map of countries and capitals, essentially. Next, we have thematic maps. And these thematic maps, there can be chloropleth maps, proportional symbol maps, isopleth maps, dot maps, cartograms. And if you're thinking right now, I don't know what any of those words mean, don't worry. I'm going to tell you on the next slides. So political maps, these are designed to show governmental boundaries of countries, states, and counties. They also show locations of major cities, and they usually include significant bodies of water. And so what you'll see on this map are colors and lines represent borders of countries, states, and cities. So this here is a map of Afghanistan, and we have rivers right here, major cities, and then political boundaries. On thematic maps, these emphasize a particular theme or special topic. So in our example to the right, we see major languages of the world. And so our theme, languages. And so each different country has a different color representing what language is spoken there. Any other irrelevant information, this is filtered out. Like population, we don't care because our map is about language. Cities in that country, doesn't matter because we're only interested in language here. So settlements, landforms, coastlines, these might be shown as points of reference. However, they're not necessary on these types of maps. What you will see on this map is that the colors are used to indicate categories related to that theme. So one type of thematic map is called a chloropleth. And a chloropleth, this uses differences in shading or coloring to show differences in values between areas. And one advantage to this map is that it's easy to read. One disadvantage to this map is that it can often be far too generalized. So for example, we have population density of Asia in 2009, and we have these different shadings because that's what a chloropleth map does. And so the lighter shading, this is 0 to 50 people per square kilometer, whereas the darker shading is greater than 700 people per square kilometer. Another type of thematic map are proportional symbols, and these symbols are placed on maps to show the location of specific data, and the size or the proportion of the symbol represents the quantity of that data. So one advantage is that these data, they're more location specific. These symbols can sometimes be misleading. So for instance, we're looking at forestry production by country in 2006 in Europe. And so these small symbols represent 0.3 million cubic meters of forest production, whereas the largest symbol represents 65.6 million cubic meters of forest production. And so we can see countries that have less forest production, such as this one here, and then those, say, such as Scandinavian countries that have a much larger forest production. So one disadvantage, again, is that these symbols can be misleading if they're not truly to size of scale. However, these data, they are much more location specific. Another type of thematic map is an isopleth, and these are also known as contour maps. And so the lines are used to connect data of the same value. For example, we can use this to connect elevation, temperature, pressure, humidity, and so you might see this a lot on weather maps. Talking about elevation, isopleth map, one type is topographic maps. So this depicts in detail the ground relief, landforms and terrain, generally in the form of contours. One other type of thematic map is a dot map. These dot distribution or dot density maps use a dot symbol to show the presence of a feature or phenomenon. For example, these might be settlements, shops, earthquake. In this case, our example looks at U.S. public libraries, and we'll see that public libraries, there's a higher density of them in the northeast of the United States than there are, for instance, say, in the west. Dots maps rely on a visual scatter to show a spatial pattern. So one other type of map, I think these maps are really fun, are cartograms. So the areas of these maps are substituted for another value, and the shapes are distorted. So it's not a true map, as the scale of this cartogram is variable. However, it can help us to represent things visually. So one thing that I really want to talk about today are fundamental cartographic conventions. So there's two big conventions I want to discuss. One is color scheme, and this is the arrangement or combination of colors on a map. And then two is typography, and this is the art and technique of arranging type. And so these are two very, very important things if we're making maps, because you can do the best analysis in the world. However, if you can't display it for an audience and convey this information to a group of people, then you may as well not have done the analysis in the first place, because if no one can understand what you've done or you can't visualize it, then it could be a challenge for those that you work with. So color scheme, it's really important to realize how much your choice of color on a map can affect the story you're trying to tell with your data. As a brief introduction to some theories behind how to use colors on map, these next few slides, they contain three primary schemes for mapping data. So one is a sequential scheme. Sequential schemes order data from high to low, and they accent the highest as a dark shade and the lowest as a light shade, or this can be vice versa. These are the best if you're mapping quantitative data and do not want to focus on one particular range within your data. So this is a sequential scheme of agriculture, and this is percent of labor force employed in agriculture in 1960. So again, we're in Europe. We're showing that 63 to 71% that are employed in agriculture in 1960. This gets a really, really dark shade, where if you're a really light shade, then that means that there's less people employed in agriculture in that country. Another is divergent schemes. And divergent schemes are best at highlighting a particular middle range of quantitative data. You'd pick two saturated contrasting colors for the extremes of the data, and then the middle range blend into a lighter mix of those two. So this is a really great choice for accenting the means of your data and exposing locations that significantly diverge from the norm. So we have the change in percent of labor force employed in industry between 1960 and 1980. So 29% is this dark green, and this is increasing, and then we have decreasing down here in this lighter color. But then these middle colors, which is kind of the means of our data, are shown in these lighter in these lighter shades that blend together to mix these two ranges. And so this is really, really good again at this is really, really good at this is really great for accenting the mean of your data and exposing those locations that significantly diverge from the norm. Finally, we have qualitative schemes. So if you're working with qualitative data, you want to pick a series of unrelated colors. So the trick is to pick a really nice color scheme so that your map looks really, really great. You can also accent particular aspects of your data by your choice of color. So for example, one strong dark color among a group of lighter colors will pop out of the map, and this might highlight a particular facet of your data against all others. So maybe that's what you want to do, but just consider your colors and what your data and what you're trying to show with your data when you're making a map. So for this map over here, it's a qualitative scheme. We're looking at the dominant sector in 1960. So we have agriculture, industry and services are equal, or services. And so in this map here, these industries, they're not related to one another. So we wouldn't want to do like a dark green, a light green, a lighter green, or anything like that. Instead, we want to have very different colors representing very different industries. So the main points to remember with color scheme: consider what you are wanting to emphasize on the map. 2, use appropriate color ramps when showing a gradient. And 3, use appropriate colors for layers. So for instance, water should usually be blue, not purple. Forest, you want to put those as green and not say blue. So just think about what you're mapping and think what would be most logical in some senses, would be most logical for mapping your data and for getting your point across to your audience. Because again, whatever your point is, that's what you want to emphasize on your map. So I've included in this slide a few sites for picking colors that are really great at helping you pick colors. These are free, they're really awesome. I would suggest you check them out whenever you start making maps. So next we're going to talk about typography, or your text for maps. So on maps, text, it competes with the graphics. It should not be placed over backgrounds that share the same color as the letters, because your letters will just blend in with the background. The eye reads text on a map letter by letter instead of through word shapes. So you really want to make sure that your text is very clear. The type size and style changes quite a lot on maps. And much map text is set in quite small point sizes. So these are all things that we want to be aware of whenever we're looking at text for maps. And I have a video on typography here, which I've provided a link to. I'm not going to go through it now, but if you want to go through this afterwards, again, another resource for you to explore. So these are a few rules for text on maps. The typeface, it must be legible in small sizes. Different styles and weights of the typeface must be clearly differentiated from one another. Individual letters must appear different from one another to help minimize misreads and misunderstandings. And then finally, typeface must be able to form good word shapes, which will directly increase legibility. So I'm going to give you some examples here in a moment. But first, we're going to talk about the essential map elements. So essential map elements are elements that you should put on nearly every map. Depending on the audience, some of these could change, but there are a few of these, such as a scale bar or inset maps perhaps, that you really need to put on every map. So we're going to go through these. So essential map elements. For me, I included the scale bar, a compass rose, so just your arrow, like your north arrow, a legend to say what's going on the map. This is my key for reading the map. A title, a good title that explains what the map is actually showing us. Perhaps you need a data source depending on your audience. They might want to know or need to know where this data came from. Who created the map? So that could be yourself, or it could be your company, or it could be your organization. That's an important thing, because then if someone else is viewing this map, they know who to go back to find more information about what your map is displaying. Perhaps you need a base map, maybe an inset or locator map, depending on the region that you're mapping. And then also I've included a neat line. So this map here, it shows some but not all of the necessary essential map elements. It also includes a few additional elements that we're not going to discuss, but I thought this was a really great map. So the first essential map element is scale. So maps are made to scale, and in each case, the scale represents the ratio of the distance on the map to the actual distance on the ground. So for example, if you have 2 centimeters on a map, this represents 1 kilometer on the ground. The scale would be 2 centimeters equals 1 kilometer, or 1 to 50,000 scale. So scale is unitless. So if it could be 1 foot represents 50,000 feet, or 1 meter represents 50,000 meters. But scale is very important because it helps us to understand the size of things that we're looking at on your map. So large scale maps have small numerical scales. So for example, a 1 to 1,000 map. It's large scale. Large scales, they show a small area but in really, really great detail. So 1 foot on the map would equal, or 1 inch on the map would equal, say, 1,000 inches on the ground. So this would be known as a large scale map. Small scale maps have a large numerical scale. So for example, a 1 to 500,000 map, you're going to be looking at a really large area. So a small scale map shows a large area, but this is much less detail. So whether you're working with large or small scale maps depends on the extent of your study region of interest. And there are trade-offs to working with both. So again, large scale map, small area. So we have this polytechnical campus, but in really great detail. Small scale map shows us a large area, so an entire country, but we have much less detail. Now there's a few different ways to write scale. So you can write it as a ratio, say 1 to 10,000, or you can write it as 1 to 10,000 with the semicolon in between. So the advantage, this is easy to read as a ratio. The disadvantage is it becomes inaccurate when the map is copied. Another example is as a scale bar. So the advantage to having a scale bar is that it's easy to visualize, remains accurate when the map is copied. The disadvantage is that some scale bars do not start at 0 and may be misinterpreted. So for example, this scale bar here doesn't start at 0. So whenever we're measuring out the map, we need to go from 0 to this 400 and then know that 0 to 400 is what represents 400 meters, not from 100 to 400. Our next essential map element is a compass rose. So a compass rose is a figure on a map used to display the orientation of the cardinal directions. So north, south, east, and west, and their intermediate points. So north normally points straight up on a map, but this doesn't always necessarily have to be the case. And within QGIS or any sort of GIS software, you have just a great array of north arrows to choose from. Next, a legend is an essential map element. So this is key to a good map. So your map legend, it's an explanatory table of symbols used on a map or a chart, and this serves as the decoder. This serves as the decoder for the symbology for each layer you used. A legend, it's not always necessary for a map figure. However, it might be. It should also be noted that a legend, it's not always necessary for a map figure. For example, a map that shows only aerial photos doesn't really need a legend. However, if you're making a map that does need a legend, then you definitely need to include one. However, if you're creating a map for the general public where you use lots of different types of symbols, then a legend would be necessary in order for your audience to be able to decode what's going on the map. Another essential map element is a title. This instantly gives the map viewer a succinct description of the subject matter on the map. Your title, it should be an answer to what or when or where. And it's not always necessary. For instance, if you have a figure caption with your map, then perhaps you don't need a title. However, if you have a standalone map, then a title would be necessary. So this map here has a great title. And then it helps us to know immediately what we're looking at on the map. A data source is another map Data source is another essential map element that I've included. So if you're using data sources or data layers that you did not produce or collect yourself, you should always cite these on your map. This tells the map reader where you got your data and where they could potentially go and get data from as well. It could be a simple line on a map that reads data provided by whatever site that you got it from or whatever source you got it from. The information for the data can also be found in a file's metadata. Another essential map element that I include is the date created or the author name. And this is just as simple as who created the map and what the date was. And so whether or not this is a necessary element on every map or figure that includes a map is very context specific. So if you just needed to, say, publish an informal map, then maybe you didn't need your name or the date created on it. However, I like to include this because then someone who's viewing this map knows who to go to and how relevant or how because then if somebody is viewing this map, then they know who to go to and also around what time or how long ago this map was created. A base map is another essential map element. So the function of a base map is to provide background detail necessary to orient the location of the map. It's not always necessary if the location of your map is already clear and obvious. QGIS, they provide a variety of free base maps for you to choose from. Another essential map element is an inset or locator map. Another essential map element is an inset or locator map. Inset map zooms into a part of a main map to show more detail, whereas a locator map zooms out of the main map to locate the map on the globe or the continent. So on our map example here, on the right, this is an inset map. On the left, lower left, this is the locator map. So now we know where we are in Japan. Again, this one is context specific. So if you're dealing with a group of people who know where you're already located, it may not be necessary. However, if you're making a map for a general audience, then typically you would like to include a locator or inset map. A neat line is the final essential map element, and this just honestly makes your map look quite complete and look really nice. So this is just a border delineating and defining the extent of geographic data on a map. So you just see this map here, it has this nice little neat line surrounding it. It demarcates map units so that depending on the map projection, the neat line does not always have a 90-degree corner. So additional considerations. One of my biggest pet peeves when looking at maps is if a map has a lot of white space or just unused space, it kind of drives me crazy. So just be careful not to have unnecessary white space around the perimeter of your maps and figures. And when you insert figures into reports, they will likely already be white space and borders. So just keep that in mind depending on where or who you're sending your map to. And if your figures have additional white space on the perimeters, it has the effect of just making your images look smaller on the page. So for instance, I have this map here. There's no neat line around this map to tell me like where it ends, and it just kind of drifts off into lots of white space. So now I have some example of good and bad maps that I want to run through with you. So these first we'll go through are examples of bad maps. So this map here, USA sitcom map. First off, it has way too much text on this map. I'm a little overwhelmed and I'm not sure what all of this text means. There's no scale bar on this map. It's a pretty confusing title. Is this places where the shows took place? Is this where they were filmed? Are this where the main character is from? I'm not sure why all of these sitcoms are just kind of scattered about the map. There's no compass rose, and there's no explanation of the color scheme. As you see, there's some states that are orange and some that are green. I'm not sure why, what is colored what. Next, we have a map that looks like it came from a newspaper clipping, perhaps. This is a pretty poor color choice. I'm not sure if all this blue area is a river, or if these are rivers that are running through it, or if this represents a certain area that's contaminated. I'm not sure. This red line around it, is that a road, or I'm still just not really clear on what's going on. There's no locator map, so we're not really sure where this is located. There's no title, there's no compass rose, and no legend. So overall, not a great map. This map here is a pretty interesting example. This is a poor background color choice. Not sure why this was selected. There's a very unclear title. Just Nathan's World Map doesn't really tell me a whole lot. The legend, there's lots of, the legend has too many significant digits. It's really unclear what this is representing. It's a poor legend placement, as one of the countries actually overlaps what looks like the legend title. This compass rose design may not be the most appropriate depending on where this map is going to. And also there's the scale bar is 0 to 12,000 kilometers, which is fine, but typically if you did like 0 to 10,000 or 0 to 20,000, that might be better. I can give or take the scale bar in this map, but there's a few other things that are definitely not great. So now that I've bummed you out with all of these bad maps, I want to bring you up a little bit with some good maps. So these are some really great examples that I have found and come across in the previous years, and hopefully you'll think so as well. So this map here looks at Charleston, West Virginia. This is meth lab locations, actually. There's a nice locator map right here in the bottom left corner. It's a very clear legend, a really great legend. I know what each of these represents. The scale bar is 0 to 20 miles. It's really great. A clear title. We have resources down here from where the data came from. It has a nice compass rose up here in the top right corner. And there's a name and date present on this map as well down on the lower left. This right here is a map of the Fukushima runoff evacuation zones. So again, this is a really great locator map. It's a very, very clear legend. Really nice scale bar down on the bottom half of the map. A clear title. It cites the data source. Has a really nice compass rose, and also gives the name and date of who created the map. And then finally, this one is population change of the US. So again, this has a clear legend, really nice scale bar, a clear title, cites the data sources, has a great compass rose, and the name and the date of the author are present on this map as well. So now that we've gone through the fundamentals of cartography and gone through some good maps and some bad maps, you're going to create a map of your own in QGIS.